Practice problems for assignment number 8, functions part 2. Example number 1 here, it's giving you a table where they want you to describe what the graph of the function would look like. So a couple of hints here. If it's a vertical line or a horizontal line, you're not going to really see an x in the problem. If it's horizontal, you're going to see y equals something, and if it's vertical, you're going to see x equals a number. All right, if it is a line, then you're going to see x to the first. But if it's a negative slope, then your m is going to be negative, and if it's positive, your m is going to be positive. But if it's a parabola, you're going to be seeing x squared instead of just x to the first. And then if it's opening up or opening down, that depends upon the a. Okay, so lines have x to the first, or slanted lines have x to the first. Parabolas have x to the second, and straight vertical or horizontal lines have a variable missing. So this first one, g of x equals -3, that's really similar to just saying that y equals -3, because g of x is the function. So if all you have is y equals a number, it's never, ever going to cross the x-axis, which means it's going to be a horizontal line. For this one, we have x plus 5. It's x to the first, so I'm not going to be choosing this or this. X to the first means it's going to be a slanted line. And since the slope here is an imaginary 1, it's a positive 1. It's going up 1, right 1, up 1, right 1. That's going to be one with a positive slope. And then this last one here has an x squared in it. Anytime you have one with x squared, you're going to be looking at the parabolas. You're not going to be looking at lines. It's got to be a parabola. But if you look at the a right here, the a is positive 2. That means it's opening upwards. So this is going to be a parabola that's opening up. Okay, so for example 4, they want you to evaluate this table here and answer a question about it, realizing that the first one says 20x to the second, and that is going to be quadratic because it has x squared. But the second one here says 4 to the x, that's going to be an exponential function because the x is in the exponent. So the first one they already did, x equals 2, they plugged it in, 2 squared is 4, 4 times 20 is 80. Here they plugged in x squared, x equals 2, so 4 to the second power is 16. So they want us to fill in the rest of that. So for this next one, x equals 3, so I'm going to make it 20 times, well, x squared, 3 squared would be 9, so my answer there would be 180. And for g of x, it would be 4 to the power of x, so 4 to the third, and that would equal 64. So you'll fill in the rest of the chart just plugging in the value of x, and then you have to answer the question. So this is what I got. Okay, so for part B, they want us to look at the values where x is greater than or equal to 3. And then we're supposed to decide if f of x is always, sometimes, or never greater than the value of the g of x, which is the one in purple. So if we're looking at the values of 3 here, we'll start at 3, and then we look at all the values of x where it goes bigger. So in the first case, for x equals 3, 180, the blue one, is greater than 64. F of x is bigger than g of x. In this case, 320 is bigger than 256. But when we go down to the next one, the 500 is smaller than the 1024. So sometimes it's bigger, sometimes it's smaller. That means we have to choose the word sometimes. For the next one, the f of x is 2 to the x. And the g of x is 85x squared. So we're just going to be plugging in the values of x and see what we come up with. So in this case, it's 2 to the power of x. They did that for the 8 already. Now I have to do it for the 9. So 2 to the power of 9 is going to equal 512. So that's for my f of x. For the g of x, I have to do 85 times whatever x squared is. Well, x is 9, so 9 squared is 81. So I have to multiply 85 times 81. And I get 6,885. And you'll do the same thing for the rest of the table. You'll take your value of x and you'll plug it in. And now I'm going to answer the second part of the question. For the problems where x is greater than or equal to 15, so I'm only allowed to look at the 15 and the values above. Does this graph or does this table suggest that f of x is always, sometimes, or never greater than the g of x? So here in this case for 15, this one was 32,000 and this one was 19, so the f is greater than the g. And in this case, 65,000 is greater than this one. So I'm going to choose the word always, because in those values only, the f is always greater than the g. Now notice that the domain that they give you matters, because if they had just said for any values of x, you wouldn't be able to say always, because over here, this number is smaller. And over here, the f of x is smaller. So it depends on which values of x that they're asking you about. Okay, graphing the equation, you need to remember that when you have an absolute value of x, it's going to look something like this. It makes a V when you're doing absolute value. So what we need to do is find the vertex, and then we have to calculate A so that we can know if it's going up or down and how steep it's going. All right, well in this case, the vertex, there's nothing added in with the x right here. So that's going to be 0, and there's nothing added on at the end either. So our vertex is at 0, 0. But A, the number in front, is 4. So that means we're going to go up 4 and right 1, and then we're going to have our absolute value. This one doesn't curve like the other one, so you just keep going up 4, right 1, up 4, right 1. So the vertex is at 0, 0. I'm going to go up 4, 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1, because a V is made of two perfectly straight lines. It doesn't curve like the parabola does. And then whatever it did on the right-hand side, you have to make it match on the left-hand side. The axis of symmetry is actually the y-axis. It's the exact middle. So you bring it down, and you bring it back up. This one's going to be different because it's a parabola. It's going to be a curve. It's not going to be straight down and straight up. So in this case, the vertex is at inside the parentheses. You turn it into a positive 1, and then negative 2 for the second part. The A here is just an imaginary 1. So if the A is 1, we're going to go up 1, then we're going to go up 3, then we're going to go up 5. So we started the vertex 1, negative 2, and we're going to go up 1, right 1, up 1, 2, 3, right 1, up 1, 2, 3, 4, 5, and right 1. And then we're going to make it match on the other side of the axis of symmetry, or you could just count up and to the left as well. So here we go backwards 1, here we go backwards 2, 1, 2, 3, 1, 2, 3, and then that's a parabola. All right, question 11 is talking about the average rate of change. So in the past, whenever you were doing lines, you did rate of change with slope. We don't call it that with curves because it's not exactly the same all the way through. It's getting shallower and steeper. So we have to find the average rate of change. But we do it much like slope. We just simply have to have a starting point and an ending point. So we're going to find the rate of change from x equals negative 4 up to x equals 2. Here's the place where x equals negative 4. And here's the place where x equals 2. So I'm going to find the average rate of change between those two boundary lines. But you have to find where the point is actually on the parabola. There's one point, and here's the point at x equals 2. So you're really technically just finding the average rate of change between those 2 points. You could use a slope formula. Some people do. I just use rise over run. So I'm going to count downwards. It's going to be going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, down 12, and then I go to the right 1, 2, 3, 4, 5, 6. To the right, that's positive. So it's down 12, right 6. You always need to reduce your answer if possible. So that's negative 2. Okay, this one's counting the average rate of change from +4 to +8. So you can draw the boundary lines at 4 and at 8, or you can just draw the dot where x is at 4 here. And when I go to where x equals 8, it would end up hitting the graph right there. So that's would be at the 8, and this one's at the 4. So I'm just going to count the slope again. This one's opening downwards. It's going down. So I'll go down 1, 2, 3, 4, 5, 6, 7, 8, down 8, and to the right 1, 2, 3, 4. So this average rate of change is going to be down 8, right 4, which is going to reduce to become -2 as well. Okay, so here we have an example of a piecewise function because it's not going the same all the way throughout. Whenever you change the interval on your domain, then the graph is changing. So we're just going to look at each piece. From A to B is the first question they have for us. From A to B, so we're going to look from A to B. That is not going up. That is not going down. It is staying the same, and that's what the word constant means. Not going up, not going down. It's staying the same. All right, the next one is from B to C, so we're going to look right there. From B to C, it's going uphill, and that's what increasing means. You're always looking at it going from left to right. For C to D, or between C and D, we have to look at it, and again, it's going flat. It's not increasing, it's not decreasing, it is staying constant. And then for the last one, between D and E, it starts to go downhill. So between D and E, the answer would be that this one is decreasing. Quick review of translating. Again, you did some of those yesterday. But in this case, this is telling you to move 2 to the right. You go with the opposite sign of what's inside the parentheses. And there's nothing on the outside changing it up or down. So I'm just going to take this whole parabola and move the vertex 2 to the right, 1, 2, and then I'm going to copy the rest of my parabola as it is. It's going up 1, up 3, so I'm going to go up 1, right 1, 1, 2, 3, right 1. You're just shifting it to the right. Nothing else is stretching or changing. But this one is an absolute value that's going to be changing, and there's nothing inside here to move it left or right. No change left or right. It's this number right here that makes it go up or down. And since it's not in parentheses, I'm going to keep the negative sign as it is, and I'm going to say down 3. So I take my vertex and I go down 1, 2, 3, and I make everything else the same. This one's going up 1, right 1, up 1, right 1, up 1, right 1. So I'm going to do that. Up 1, right 1, up 1, right 1. And I'm going to make it match on the other side. Don't forget, when you go to make your graph on ALEKS, you have to show at least these 5 points before it will accept it and go ahead and finish the graph for you.